Oh, Tomasz.
What's happening?
What's happening on node 9? I saw a heap dump.
No, it's just Java options which says that it should dump heap error. You mean picked up Java options?
Okay. Phew. That's not the way I wanted to start the testing session. All right, fantastic. Thank you for taking me down off the ceiling here. Okay, so I've put a link in the chat window for today's worksheet. If you could either come off mute or post in the chat. If you're planning on running a node, let me know when you've got the proper version of node installed, and I'll know when we're ready to get more started. While I'm waiting for that, I want to talk a little bit about what we're doing and what we're using today. So let me share my screen. So we are working as a development team towards the launch of a public testnet starting next week. And there is information in this page. It's on the RChain wiki. It's called RChain Public Testnet Information. And it describes the rollout of a public testnet. It's going to come in phases. And so what you can expect next week is very similar to what we're going to look at today. We are going to look at a testnet that's running with known validators that are running on RChain infrastructure. We are going to look at the ability to deploy Rolang to those known validators and be successful in doing that and seeing that being added to the blockchain. What we're not going to do today is do the Alice pays Bob scenario. We're not quite ready for that, and we're resolving some issues to better support that. So that's coming and not part of our testing session today. We have our kind of just a quick description of what that public testnet is supported by. We are using machines in Google Cloud to support and provide backbone infrastructure for the public testnet. There are a total of 10 nodes. They're running on, 4 CPUs and 16 gigs of RAM. Is that correct, Tomasz?
Yes, it is.
Thank you. And they are one is serving as a bootstrap, and the rest are serving as validators. And they will provide the backbone infrastructure for our public testnet. We are happy to be in a situation where we can monitor those nodes and understand how they're performing. We're also in a scenario when, as we are monitoring those nodes, if we notice for whatever reason they are either struggling or go down, we are in a situation where we are able to restart nodes individually, and being able to do that to support maintaining a live network, even if we have to kill and restart a node. We are enjoying the fact that the block store implementation supports quick catch-up, and that will help us with restarting nodes and bringing them back into the network environment. What else should I talk about? We did discover an issue over the weekend as we were running we did a long-running testnet test and ran into some issues. And we've seen that here before in these tests. And the issue is, a slowdown of the time it takes to add blocks. So we've seen that here in community tests, where as the blockchain gets longer, it becomes slower and slower to add blocks to the chain. We've also observed that when people are using Node to evaluate Rolang, the more contracts they evaluate, the longer it takes to evaluate them unless they clear our space and start over. And so we do have what we're calling a short-term solution to fixing that, and we tested that yesterday, and it makes Node just blazing fast, which is good news, and we are not observing that slowdown of adding blocks, either in the eval mode of Node or in using it to build a blockchain. It's not a long-term fix, though, and the reason it's not a long-term fix is because it will not be sustainable. For example, if somebody deploys a very large contract. So we do intend, as of about 45 minutes ago, we do intend to move forward with the short-term fix for our public testnet. And what that will mean is when we launch public testnet next week, we will have to limit the size of contracts that are coming into the network simply because of this issue in our space. I don't see it as a big blocker in terms of people being able to join the public testnet and do the things that you would want to do at this point, which is demonstrate and prove to yourself that you can deploy relatively reasonable contracts to the blockchain and prove to yourself that you can move tokens around using our wallets and cost accounting features. But what it does mean is it's not sustainable, because at some point we do need the ability to support these larger contracts. And so we also have what we're calling a longer term, more permanent solution. We have an idea for what that solution is like, and we're working today to understand how much time it will take to implement. So that is a lot about our plans for the public testnet and kind of where we are. Does anybody have any questions about that? Good news. Okay. So let's just take a look and see where we are. I hear that blocks are forming. Okay. So if you are running a node and you are ready means you've got RDoctor installed and you have the correct version of node installed. I'm putting in the chat window here the address of the Bootstrap node. And I will run against that as well. So if you're watching on my screen on the left-hand side, I am starting up a node that will connect to the public testnet. On the right side of my screen, you will see I'm aggregating logs of all of the nodes that are currently on the public testnet. So mine should appear there as we get started. I want to call out one of the improvements we've made very recently. One of the things that we noticed in community tests, and grateful for the community for helping us find this out, is that in a busy network environment, sometimes it was difficult to get the Genesis block because your node got busy doing other things. And so we've made a correction to that where when you're starting up node, you will not allow Casper messages to come through until you've made your first peer, and that assures that you're going to get that Genesis block and start Casper, at which point you're ready to receive Casper-related messages and start adding blocks to your local DAG. And that's what you're observing on my node here. I'm catching up to the state of the network, which is not very big at this point. We just started it. I also want to show you, let's see if I can find it. Yikes. This is also an improvement. We had we observed problems if you were in the network and it was busy and you didn't know you wanted to know what the state or the current fork choice of the network was. We had this feature where you could request the fork tip from peers, but Node would get really busy and you didn't always receive that message. And now that's very much working. And so what you can observe here is I received the Genesis block. And as part of that, I processed the Genesis block. I made a transition, which means that Casper started. And then at that point, I requested from the peers what the current fork choice tip is, and they responded in kind that it is block number 2. And of course, then I had to ask for it and add it, and that is what you observe here in logs. And so if we come over here, actually, let's come over here. And you'll see that I now have my node observes up to block number 3. It's not a big deal when you see that there are multiple instances of block number 3. Keep in mind we have multiple validators. the work of consensus is to come to consensus and agree on what is in fact block 3, and we will see this resolve over time. That's not an emergency or a problem. All right, I see Drawer is connected. Who else? And Phil, well done. And Tomislav, everybody.
Kelly, quick question. How come your show blocks shows all of them?
It shows to the most, well, let me be very clear. Here is how I understand it. Yeah, here's how I understand it. When you ask to show blocks, it will show you all of this information about the most recent block number that you have. So I have, in this situation, there are 3 instances of block number 3. That's how I understand is why I see three block number 3s here. Does that make sense?
Yeah, that makes sense. I only have one of them though. So
yeah, so that's it. Which one do you have? What's your?
The last one. So
you have the last one.
A14.
Okay. Interesting.
Okay, so now I have all of them. So
okay, good. Now you're not left out. Okay, so you guys are all connected. It sounds like from Drawer you guys are catching up and are not observing any problems with that. So the next thing that is important as part of the public testnet. So number 1, you want to be able to start a node and connect to the testnet. Number 2, you want to be able to run alongside with it. So as our validators are proposing, you should observe your node continuing to add blocks. And then the third thing we want to be able to do is deploy Rolang to those validators and have that added into the blockchain. So that's the part we're going to play with now. And to do that, we're going to need. So we do this deployment by specifying gRPC host, and that's how you can deploy Rolang to these testnet validators. And I lost track of where I put those addresses. Okay, so let's, for the moment, I'm going to put in the chat window here. Let's use this node, that is node. Oh, hold on, Tomasz, is node 0 a validator, or is that purely Bootstrap?
They're already, sorry, they're all validators.
They're all validators. Okay, fantastic. So the chat is the IP address that you can use. You'll have to correct that m dash. It should be two dashes before gRPC host. And let's experiment with deploying to that node. I'm thinking, I think the problem is that node's not auto-proposing. Is that correct, Tomasz?
I know 3 of them are auto-proposing.
All 3, okay. Is node 0 auto-proposing?
No, node 1, node 5, and node 9.
Okay, node 1, node 5. Okay, so I've misled you all. Please disregard the IP address I put in the chat and look at this one.
Oh, I see.
Yeah, let's use the second one ending in 146 because that is a validator that is proposing. So the exercise here is deploy some Rolang to that validator, and let's keep track of it and see if we can make sure that it gets into those blocks. And that is validator number 1. Nope. This one. Okay. So if I give that a try, let's see. Oh, shoot. All right, so if you're following along on my screen, after you observe me make all kinds of typing errors in my deployment command, I have asked to deploy to node 1, which is the node that you see on the right-hand side of my screen in logs. That did not work out because I got a timeout exception.
Now let me check.
Okay. And so did everybody else. Okay, let's troubleshoot this. Give Tomasz a minute.
It should work now on node 1.
On node 1, okay, so let's try again. Yes, that went very swiftly. So, and you can see over here that that happened. We can observe that people are deploying to node 1. Node 1 is receiving those deployments. And in a moment, we'll observe that node 1 proposes those deployments in the content of a block.
I also deployed successfully.
Yay, good news. Thank you.
Okay, it's fixed on nodes.
Somebody's playing high card row. And dining philosophers. Okay, so it should be, moves too fast. I think it's in this blog. Let's see if my node has added it yet. Yep. Okay, so we can confirm that people were successful deploying to a known validator and having that validator propose those deployments in a block. So that is good news. Okay, so Tomasz, let's do this. And people who are participating in the test, let's just want to be really clear that you guys get to participate and be community testers, and that means sometimes being on the raw cutting edge of all the things that happen here in the development of the RChain platform. So this is something that we're giving a try, and it's not quite curious to see how it goes, and we're doing that in public. And that's okay. So Tomasz, what I'd like to do is to for you to kill one of the validators and then bring it back up. And can you just tell me which one you're going to do so I can watch?
Let's see. How about 3 and 6?
3 and 6? Okay.
No.
Which one did it end up being?
I forgot to uncheck restart all nodes.
Okay.
Nice.
Tomasz, I saw a big drop in peer count. What did you end up doing?
I first started only those 3 nodes.
Okay.
I mean, those 2.
All right. Well, I went from a peer count of 12 down to a peer count of 3.
Well, let me check.
Okay.
Yeah, I think the script that is running when you kill it in the runtime, it's stupid that then continues running in background. So I guess we will have to yeah, I guess it restarted more nodes than it restarted some nodes before it got killed. Because stopping node its first task.
Okay. Okay. And as I see them coming back up. So that's good.
So you want to try to do it again? On
I
your keyboard?
do, yeah.
So now only 2 nodes.
Okay, which ones?
Node 3 and node 6.
Okay. Okay, yep, I saw those 2 drop.
And crash.
Strategic kill. Oh, it did crash. You are not wrong. Why?
Well, I'm not sure.
Did you? Oh,
Could you scroll a bit down?
down.
There is LMDB.
It's the LMDB thing. We've seen that
Yeah.
before.
Oh, it starts here. Sig bus. It's sig bus is.
Do you need any of this?
I can look. I can find
Okay.
it.
But that's the same one we see sometimes, right? When you attempt to kill a node via Control C, and sometimes, rarely, but from time to time we have seen that, right?
Yeah.
Okay.
Sig bus is bad memory access.
Yep.
So do you want to do it again?
Yes, please.
So now only 1 node, node 3.
Okay.
Oh.
Oh. Why is that? Okay, so we're saying because our good friend uncaught exception assertion failed is back. And seems to be related to this block.
Did we include cost accounting?
Say more about what you mean by include.
Well, is it active in any sense?
We're running off of dev, so whatever's in dev, we're running against.
Okay, because
But we've also been running a testnet with dev over the past several hours and have not seen this. So it's possible, something to consider. We have community testers deploying to validating nodes. Is it possible that what they're deploying could have caused this?
well, so it says that the block hash is mismatching, and that's because actually, yeah, I'll think a bit.
Okay.
Yeah, it says before recording invalid block for invalid block hash.
Interesting.
We can start it with clean data directory.
Yeah, so let me make sure I remember what's going to happen in this scenario. So now that we have this this error floating on the network, eventually, is it true that we won't be able to continue to build? Is that right, Kent? Once we see assertion fail?
Yeah,
Okay.
yeah, that node is dead at least.
Yeah, that node will die and then it'll get passed around, right?
Yeah, unfortunately, do you see a bunch of those messages?
Hold on, let me see. I'm only looking at node 3 right now.
So at least the way the algorithm works is if it marks an invalid block, it tries not to pass it around.
Yeah,
Unless it's, what did you say one more time, please?
other nodes look fine.
One more time? Other
Yeah,
nodes what?
sorry, Master garbled.
Sorry, that other nodes looks fine.
Yeah, I agree.
Yeah, so the only reason why it would get passed around is if another block decided to build on top of that, and so like it got pulled in as a dependency. But otherwise, yeah, if it's invalid, it won't be passed around.
So let's clean it and restart.
Just the
node
one. Yeah, just node
Yeah.
3.
Or I would just keep it down.
Well, I mean, it's not a, it's a very much in the realm of possibility that this happens, right? That we get an assertion error on a node that's backboning testnet and need to kill it and bring it back.
So let me just back up the
Sure.
directory.
But now we do have blocks building on it.
Oh, so the network is host.
Well, not yet. I haven't seen any other. I see that, for example, I see block 18 is built on that block. Am I reading that? I think I'm reading that correctly.
Yeah, I think too.
Okay, but I haven't seen any other node show up with the assertion error. Oh. I'm trying to think through this. I'm trying to think through this scenario. There was an assertion error, so we killed node 3. And
Not yet, not yet.
I know, okay, but let me just talk through this. We could kill node 3, clean it up, and restart it, but the block is still out there. So as soon as it rejoins, it's going to get the block. Kent, does that make sense? When we see this error, it truly is the whole network that dies?
No, you just gotta keep node 3 down.
Forever?
Or clean it.
Yes, or clean it. Yes.
Okay, but does it make sense when it's my impression that that block is out, it wasn't just on node 3, or was it? That's the part I'm confused about.
Well,
No, it wasn't just on node 3 because I have it. It's on my node.
I see. I don't know what's going on.
Okay, well, let's just watch and find out then. Correct, Phil. It was shut down on purpose. Yeah, Phil, so just calling out in the chat, the crash error with the LMD, it does indicate database corruption. It's exactly what happens. And it's one of those bugs that we've seen. We don't see it very often. We'll have to investigate why we saw it today. Oh. Oh. I hadn't considered that. Tomasz, are you free to listen?
Yes, I'm here.
Okay, so when the first time we killed node 3 on purpose, and you got the error or the shutdown error,
Yes,
did you clean that node, or did you restart with the block store?
I did not. I restarted the block store.
Okay.
So that could be the cause.
Yeah, it could be. Thanks, Phil.
Yeah, it's possible that some blocks or some state was saved
Mm-hmm.
because it crashed.
Yep. Interesting. So for what it's worth, we've continued to watch the blockchain grow. We continue to see node operators deploy to known validators, and we do not see any other node presenting with the assertion error. And that was in block 16, and we're up to 27.
Kent, isn't it possible that the node just read wrong state and the block was actually okay?
No, because what the error says is that we hashed the block that we received, and the hash that we computed was not equal to what the block said its own hash was.
Okay, I see. And isn't it possible that this block was loaded from database instead of receiving it from network?
Oh, I see. No, it's not possible because we only do validation when we receive the block, and we don't
Okay.
validate it after that. So yeah.
Okay.
Can you take a look at the Zoom chat? Phil has some questions that I can't answer.
Yeah, that would be an issue, Phil, but it's not going to give that specific warning message. It would crash the node somehow else, because that error message only happens when we receive a block and attempt validating it. Yeah, as I said before, like we don't do that validation after we add the block.
Tomasz, I lost track of where we are. Did node 3 come back up?
No, we didn't decide whether you want to restart it or not.
Okay, so let's do this. Let's leave node 3 down. And what do you guys think about let's kill another node?
So 6.
Sure.
Okay, going.
And so I observed that one shut down as expected.
Mm-hmm.
Yeah, okay.
What's interesting that even though I give it 4 kilobytes of RAM as starting memory, it's still taking up just 2 and 6. That it doesn't seem like it would be short on memory. It just doesn't consume that much.
Yeah.
Yet.
I think that was and I think that was the finding the last time we investigated this, that it wasn't
So hungry.
out of memory. Yeah. Okay, so I'm observing node 6 came back up. It pulled from the block store and got the Genesis block. I think.
Oh, here.
Yep.
Yes.
Okay. And I see it having, dagnabbit.
That's not 6.
That's a different block.
Yeah, it's a message.
But it's a different block.
Yeah. Sender ID 198.
It's block 32.
Yeah.
Yep. Okay. So this really is a thing. It's really happening, friends. So in the first time we did this, we had we did not have a successful shutdown, and we hypothesized that the restart and then the assertion error was perhaps related to that. But we have in this case a very clean shutdown, a restart, again pulling from the block store, and an assertion error at the block where it left off. What do you think, Kent?
What is the sender ID, by the way?
The sender ID for that block?
There is recite block number, then the block hash, and then there is sender ID.
Oh, it's the validator.
I don't see that it connects any validator that it connects to doesn't begin with 198.
Oh. Maybe I'm misunderstanding what that field is then. Although
So the node ID is not the same as the sender ID.
the sender ID is the public key of the validator, right?
Oh, I see. Yeah.
It's the hash of the public key of the validator.
Oh, okay. Yeah, because there it is in the bottom file.
Yeah, it corresponds to nodes 140F7. It's the second or third node it connects to.
So it's node 3?
It's node 9.
Node
It's
9, okay.
Yeah.
Got it. Okay. Kent, do you need to see this again? Where we kill a node and get this error?
No, I think it's, well, I don't know what the issue is, but it's pretty clear. I guess maybe just the error message there, if you could paste it in the chat or the Discord. Yeah, just like all of those until what I can see on the screen. Yeah, thanks.
You want all of these?
Yeah, maybe until, I don't know, Pierce 9. That's, yeah.
Okay. All right, Phil, block hash checks also for deploy hash. I don't know the answer to that. Kent, can you look at the Zoom chat and answer Phil's question?
Yeah, it hashes everything in the block. And the way it does that is it first hashes the body, which includes all the deploys and so on. And then that goes into the header. And then the header is hashed, and that becomes the block hash. So in theory, like everything in the block should be covered.
do think it's interesting that this doesn't spread.
I'm just watching other validators, and they just receive the block and add it to blocks down.
Yeah. I guess the reason it's interesting to me is because when we've seen this error before, it spreads and it spreads quickly. Kent, can you take a look at Phil's comment, please?
Well, it's a code snippet. I guess, do you have a question or? Like, I do think the way to debug this is break down the hash, like do smaller parts by parts and figure out which part of the hash is mismatching and causing the larger hash mismatch.
Okay. I like the alliteration. All right, so we are about 5 minutes to the top of the hour. Let's do a recap of where we are. So we are, today we focused on running a test against our, what will be the public testnet backbone, which is a collection of 10 nodes, one serving as a bootstrap, all of them acting as validators. We observed our community testers connecting to that network successfully, receiving the Genesis block, catching up to the state of the network, being able to deploy rolling contracts to a known validator, and having that known validator then propose those deployments in the form of blocks and adding them to the DAG. We experimented with killing a backbone node with the intent to restart and observed the assertion error, which we have a good plan for investigation on. We also observed again today the shutdown problem, and we need to investigate that as well. Is there anything else that we should capture as things to take away from this? Oh, Kent, Phil does have a question now.
The second and third. Oh, this is in the. Yeah, that's I guess the sub checks that I was talking about. Although we don't really make good use of it because, yeah, we don't print out which hash was the one that was mismatching. So, yeah, we got debugging work to do.
It's our favorite. Okay, well, excellent. Hey, node testers, thank you so much. This is very helpful as always. I really appreciate the time that you commit to doing this. And so we're going to wrap here, and we will be back again next week to do some more work in the space. So thanks again for your time today, and I look forward to working with you again next week.